Hi, welcome to question paper discussion. Today we are going to discuss about paper 7, probability and statistics of A level. We will be discussing 2019 paper, second variant. Shall we start with the first question? Here we go. The random variable x has a distribution which follows a Poisson distribution, and find the probability of x equals 2. So probability of x equals 2 is equal to e to the power of minus 5 times 5 to the power of 2 by 2 factorial, which will give you an answer of 0.084 224 and goes on, which is approximately 0.0842 rounded to 3 yourself. So that's the first part. Let's move on to the second part. It is given that probability of x equals n is given to be probability of x equals n plus 1. Write down an equation in M. So we all know that it is following a Poisson distribution with 5. So probability of x equals n will be e to the power of minus 5 times 5 to the power of n by n factorial, which is equal to probability of x equals n plus 1. So e to the power of minus 5 times 5 to the power of n plus 1 by n plus 1 factorial. So that would be enough to form an equation, because in the second part you can see, third part you can see that find the value of n. So taking that, I can cancel off e to the power of minus 5 on both sides. So hence it will be 5 to the power of n by n factorial, which is equal to 5 to the power of n plus 1 by n plus 1 factorial. Now this is quite easy. We can just cancel off the common term, but I would recommend you to show how these terms are being cancelled. Let me write 5 to the power of n by n factorial equals 5 to the power of n times 5 to the power of 1 by, I'm going to split this as n factorial times n plus 1, because n plus 1 factorial is 1 times 2 times etc. n, that is n factorial, times n plus 1 will be n plus 1 factorial. So it's quite fine if I write n factorial times n plus 1. So it will be easy for you to cancel off the common terms. So I'm going to cancel 5 to the power of n, 5 to the power of n, n factorial, n factorial. So what is remaining is 1 on the left side, and on the right side you can see 5 by n plus 1. Okay, so cross multiplying, you will get n plus 1 equals 5, so n equals 4. That's a final answer. Let's come back to the question number 2. The random variable x has mean 372 and the standard deviation 54. Describe fully the distribution of mean of the random sample of 36 values of x. So here we know that n is 36. We have a mean, population mean. We can write population mean as 372 and the standard deviation of 54. Okay, so now we are going to describe the distribution of the mean. So that would be x bar follows a normal distribution with 372 comma 54 over root of 36, which can be written as x bar following a normal distribution with 372,9. Okay, so let's go to the second part. The distribution in part 1 might be either exact or approximate. State a condition under which the distribution is exact. So this is an approximate or an exact. This is what they're asking for. This can be an exact only if the population distribution is normal. So exact only if the population distribution is normal. That would be fine. Let's move on to the next question now. It is claimed that on average a particular train journey takes less than 1.9 hours. The time T hours taken for this journey on a random sample of 50 days are recorded. The results are summarized below. So here it's given to be n equals 50, sigma t is 92.5, sigma t square is 175.25. Calculate unbiased estimates of the population mean and variance. So we know that the estimated mean will be sigma t over n, which is given to be 92.5 over 50, which will give you 1.85. Moving on to variance, estimated variance equals 1 by n minus 1 times sigma x square minus sigma x the whole square over n, which is 1 by 49 times 175.25 minus 92.5 the square by 50. That will be equal to 1 by 49 times. When you calculate this, you get 33 over 8, and multiplying you get 0.0841836 and hold on, which is approximately 0.0842 rounded to 3SF. So that was quite simple. Moving on to the second part. Test the claim at 5% significance level. So the question says that it is claimed that on an average, a particular train journey takes less than 1.5 hours. So that's the claim. So our null hypothesis will be that the mean is 1.9 hours, but the claim is that it is less than 1.9 hours. So our significance level is 5%. So hence significant level in terms of z will be 5 was of 0.05, which is going to be minus 1.645. Our test stat is found to be 1.85, and the z of test stat z will be 1.85 minus 1.9 over the root of 0.0841836. 8336 and goes on by 50. That will give you a value which is negative 1.2185, which is approximately negative 1.219. So if you compare this, so this is our population mean, this is our left-tailed critical value, which happens to be minus 1.645 in terms of z, and we got a value test stat x bar corresponding z value, we got it as minus 1.219, which happens to fall to the right of 1.645. So we can write here minus 1.645 is less than minus 1.219, which falls in the acceptance region. So there is no evidence that the mean time is less than 1. So that's the conclusion. We have come down to the conclusion that there is no evidence, there is nothing to support the claim, hence we go with the null hypothesis. Moving on to the next question, number 4, the heights of a certain variety of plant are normally distributed with mean 110 centimeters and a variance of 1050 centimeters square. 2 plants of this variety are chosen at random. Find the probability that the height of one of these plants is at least 1.5 times the height of the other. So the height is given to be a normally distributed variable with 110 centimeter population mean and a variance of 1050. So 2 plants are chosen at random, say H1 and H2. We have to find the probability that one of them is at least 1.5 times the other in terms of its height. Or it can be the other way around as well. Probability of H2 greater than 1.5 times H1. So we have to think about both the scenarios. So let's take the first one, probability of H1 greater than 1.5 times H2, which can be written as probability of H1 minus 1.5 H2 is greater than 0. So we need to know what is the distribution of H1 minus 1.5 times H2. So expectation of H1 minus 1.5 times H2 will be 110 minus 1.5 times 110, which will give you negative 55. Similarly, variance of H1 minus 1.5 H2 will be 1050 plus, as we don't subtract the variance, 1.5 square times 1050, which will give you 3412.5. Alright, so let's get into the probability that H1 minus 1.5 H2 is greater than 0 is equal to 1 minus phi of 0 minus minus 55 over the root of 3412.5. That is equal to 1 minus the phi of 0.942, which is equal to 1 minus 0.8269. That will give you 0.1731. That's a probability of H1 minus 1.5 H2 greater than 0. Similarly, probability of H2 minus 1.5 H1 greater than 0 will be the same value, 0.1731. So hence, the total probability, or the probability that H1 minus 1.5, H1 greater than 1.5 H2, or H2 greater than 1.5 H1 is equal to 0.1731 plus 0.1731, which will give you a total of 0.3462, which is approximately 0.346 rounded to 3SF. So you have to be very careful not to forget the other part. Now let's move on to question number 5. The manufacturer of a certain type of biscuit claims that 10% of packets include a free offer printed on the packet. Jyoti suspects that the true proportion is less than 10%. He plans to test the claim by looking at 40 randomly selected packets. And if the number which include the offer is less than 2, he will reject the manufacturer's claim. So please read that particular question. So the final answer is 0.0266 and 0.123. Rounding it to 3SF. The second part, so fourth part, use your confidence interval to comment on the manufacturer's claim. So the manufacturer was having a claim that is always going to be less than. You can see, so that was the manufacturer's claim, that it is 10%, and our confidence interval limits, you can see that 10% is within this confidence interval. Hence you can say that 10% of manufacturer's claim is within the confidence interval. Hence, accept the manufacturer's claim. All right. It should have been manufacturer's claim of 10%. Okay. Manufacturer's claim of 10% is within the confidence interval, hence accept the manufacturer's claim. All right, moving on to the question number 6. X is a random variable with probability density function given by f of x a over x squared within the limit 1 to b, otherwise 0, where a and b are constant. Show that b is equal to a by a minus 1. So we start with what we know about it, of probability density function. We know that integral minus infinity to infinity f of x dx is given to be 1. So which means here integral 1 to b a by x squared dx is equal to 1. So integrating, you will get x to the power of minus 2 plus 1 by minus 2 plus 1 between the limit 1 to b equals 1. By supplying the limits, you will get a times minus 1 by b plus 1 equals 1, which will give you b minus 1 by b or you can write this as ab minus a, which is equal to b. So we need ab minus b equals a, b times a minus 1 equals a. Therefore, b will be a over a minus 1. That's the answer that you need. A over a minus 1. There. Given that the median of x is 3 by 2, find the values of a and b. So we know the formula of median, integral negative infinity to m f of x dx is half. So we use this formula. So starting with the lowermost limit, which is 1, to the median 3 over 2, f of x dx is half. That is integral 1 to 3 by 2 a by x squared dx equals half, which is a times x to the power of minus 1 over minus 1 to the limits 1 to 3 by 2, that is given to be half. Therefore, by supplying the limits there, you will get you will get a times minus 2 by 3. It is 3 by 2 when you substitute it becomes minus 2 by 3 plus 1 given to be half. So it is a times by 3 is half. So a equals 3 by 2. Substituting the value of a in our b, we have b is equal to a by a minus 1. Substituting the value of a in this, we get b equals 3 by 2 over 3 by 2 minus 1. That will give you a value of. So hence a equals 3 by 2, b equals 3. All right, let's move on to the next question. The next part of this question, use your values of a and b from part 2 to find expectation of x. So we know that the expectation of x equals integral x fx dx, which is given to be integral 1 to b x times a by x squared dx, which will be A times integral 1 to b cancels. So that becomes 1 by x dx. And that is, when you integrate that, it will be natural logarithm of x within the limit 1 to b. Now, we know the values of a and b. So a is 3 by 2 within the limit. B is 3, so ln of 3 minus ln of 1, which is 3 by 2 times ln of 3 minus ln of 1 is 0. So hence your answer will be 1.6479, which is approximately 1.653 SF. Moving on to question number 7, all the seats on a certain daily flight are always sold. The number of passengers who have bought seats but failed to arrive for this flight on a particular day is modeled by the distribution binomial with 320, 0.05. Explain the number 320 represents in this context. So in this context, you can see that the number of passengers who have bought seats but failed to arrive is modeled by a distribution. It's a binomial distribution where you can see this is the maximum number. So what is 320 representing? It's the total number of seats available, or you can also that the maximum number of passengers allowed. Any of these would give you a valid answer. Second part, the total number of passengers who have bought seats but failed to arrive for this flight on 2 randomly chosen days is divided by x. Use a suitable approximating distribution to find probability of 2 less than x less than 6. So we know that x is a binomial distribution with 320, 0.005. So we need a suitable approximating distribution. This can be approximated using a Poisson distribution. Why? Because n is greater than 50 and p is quite small, or np is less than 5. Hence, this can be a Poisson distribution with 1.6. This is for one particular day, and we need it for 2 days, so our lambda is going to be 3.2 for 2 days. So we need to find the probability of 2 less than x less than 6, which is between 2 and 6, 3, 4, and 5. So probability of 3 plus probability of 4 plus probability of 5, which is equal to e to the power of minus 3.2 times 3.2 to the power of 3 over 3 factorial plus 3.2, 4 over 4 factorial plus 2 to the power of 5 over 5 factorial. That will give you an answer of 0.514688, which is approximately 0.515 rounded to 3 SF. All right, so moving on to the next part. Justify the use of your approximating distribution. I've already discussed in the previous one. We have here n equals 320, probability was 0.005. So we used Poisson because n is equal to 320, which is greater than 50, and np is 1.6, which is less than 5. So since n is greater than 50 and np is less than 5, boson is suitable. All right, so we have got 2 marks for this. 1 mark possibly for stating that n is greater than 50. The other mark will be for stating np is less than 5. All right. After some changes, the airline wishes to test whether the mean number of passengers per day who failed to arrive for this flight has decreased. So during 5 randomly chosen days, a total of 2 passengers failed to arrive. Carry out the test at 2.5% significance level. So here we have a null hypothesis saying that the lambda is supposed to be 8. Okay. And the alternate hypothesis is that it has been decreased. We know that X is a Poisson distribution with 1.6, and this is for 1 day. Here we are talking about 5 randomly chosen days. So 1.6 times 5 will give you 8. So an expectation of 8 is being mentioned or given here, but the claim is that there is a decrease. So the alternate claim is a decrease. So our observed value is 2. So during your 5 randomly chosen days, a total of 2 passengers failed to arrive. Now this we have to test at 2.5% significance level. So we can write here that reject H0 if probability of x less than or equal to 2 is less than 2.5%. So probability of x less than or equal to 2 will be e to the power of minus 8 times 1 plus 8 plus 8 square over 2 factorial, which is given to be 0.01375, etc., which is approximately 0.0138, and that is less than 0.025, which is our significance level. Hence, we can say that it falls in the rejection region. So we can write here there is enough evidence to prove that the number of passengers failed to arrive has decreased. There is enough evidence to prove that the number of passengers failed to arrive has decreased. So hence we have come to the final question of this particular paper. If you have any doubt, please do comment. I'll be coming with another paper very soon. Thank you.